Hello, we're going to show you a couple of volcano experiments you can do at home. We both work at the Manchester Museum. My name's David.
I'm Hannah.
And for the first experiment, we're going to show you how to erupt a volcano from a tonic water bottle. First of all, you need a bottle of tonic water. We're using diet tonic water, which seems to work best. You also need some mints. We're using Mentos. These seem to work best, so try and get hold of these if you can. And also some paper to roll up into a tube. So Hannah's going to show you how to do this experiment.
Thank you, David. Okay, first of all you need to make a tube to release the Mentos into the tonic water with. So the easiest way to do this is to wrap a bit of paper around your packet of Mentos, tape it together to make the tube. We're actually going to be using a clear tube so that you can see what we're doing. So then we need to put some Mentos into the tube. So if you could hold this for me. If you put about half a packet of Mentos in. There we go. And keeping hold of the bottle. Thank you, David. Then if you open up your tonic water, and you need to put it down somewhere flat.
It's really important you try and find somewhere flat, otherwise it makes a real mess. Or perhaps even do it outside.
Thank you very much. Okay, so now we're ready. Right, okay, so then you just need to release the Mentos into the tonic water and make sure they all go in one go. So, okay. There we go.
So Hannah, how does that actually work?
Well, good question, David. Basically, Mentos have got a very heavily pitted surface, which means that they've actually, it's a bit like a golf ball. Basically, they've got a huge surface area despite their small size. When we drop the Mentos into the tonic water, what we're doing is we're triggering the CO2 to escape from the tonic water. Now, with the heavily pitted surface area, we basically have a large site for the bubbles to all form on as the CO2 escapes. As the CO2 escapes as a gas, the volume of the tonic water increases and the pressure response pushes all the tonic water out of the bottle. Also, we have gum arabica in the Mentos, which basically thins, it sort of reduces the surface tension of the tonic water, which makes it easier for the CO2 bubbles to form, thus aiding the eruption. But this is all well and good, David. How does this relate to volcanoes? What has this got to do with the real world?
Well, I'm really glad you asked, Hannah, because it works in a very similar way, actually. Rocks inside a volcano are usually liquid and quite molten because they're really hot, and they have a lot of dissolved gases inside them, mostly because they're under really high pressure deep inside the volcano. And this is what they actually look like deep inside the volcano, so big crystals, lots of dissolved gases. But when these rocks, these molten rocks actually come near the surface, the gases actually come out of being dissolved because of the lower levels of pressure. So here we have a piece of frozen pumice, a solidified pumice, where the actual gas is preserved in these bubbles all over the rock. And when the dissolved gas comes out of these rocks, it can be really explosive and quite violent, just as we've seen in the experiment today. And sometimes it's so violent that rocks that were really deep in the volcano and really, really hot are thrust up to the surface really, really fast, and they suddenly freeze at the surface. And this is a nice example of that. This is a rock called obsidian, which is volcanic glass, which is super cool. Okay, now we'll show you a second volcano experiment, which involves using the bottle from the previous experiment and baking soda. So here are the ingredients you actually need. We've got some baking soda, some washing up liquid, some vinegar, the bottle, which is now empty from your previous experiment, some red food colouring, some plasticine, and it's handy to have a teaspoon as well. We need to cut up the bottle for this experiment, so it's probably a good idea to get an adult to help you with that. And also, this experiment smells a bit later on, so you could open a window as well.
Or outside.
Or outside would be good as well. So how do we actually do this then, Hannah?
Okay, well, what we're going to do is we're going to first of all make our volcano cone using the bottle from the previous experiment. So as you can see here, you need to cut about 2 centimetres down from the top to make your magma chamber, and then you need to cut up to about 4 centimetres of the rest of the bottle to make your volcanic cone. You need to keep hold of the remainder of the bottle for later. Okay, so what we then do is we have here a template for a volcano.
Which you can get from our museum website.
So if you colour this in, you can decorate it to make it look like a volcanic cone, like mine here. So what we're going to do is we are going to take this and we're going to pop it into the bottle, like so. And we will be using the top of our bottle with the plasticine placed around the top to make our volcanic chamber. This will stop the top of the bottle falling through the crater. Okay, so before we do anything else, we need to make our activation fluid, which is about half a bottle, this bottle of vinegar, which is about a quarter of a pint. And pour that in. Okay, then we need some red food colouring, just a couple of drops. Okay, and to make it a bit thicker, put in a few squeezes of washing liquid. Okay, give that a little stir. This is our activation fluid. Right, then we need to load up the volcano with the baking powder. So if you don't really need to fill it more than halfway up. So just a couple of teaspoons should work. Okay, and carefully place that in. Now, we can pop the top of the volcano back in.
Okay, now we'll see if we can actually make it erupt. So if you get your activation fluid and squeeze the bottle like that, that makes a lip so you can pour it out really accurately into the top of your volcano. So here we go.
There she goes.
So it's actually starting to come out of the top of the cone now, as the gases are actually coming out of the liquid rock.
It's not quite as explosive as the other one, but not all volcanoes erupt explosively.
That's right. Some of the volcanoes in Hawaii actually have really liquid lava, which you can actually run away from. So not all volcanoes are really dangerous. It's actually a piece of real lava from a real volcanic eruption.
So that used to be really hot.
This used to be liquid, just like you can see down the edge of the volcano. And this is what we actually call ropey lava, because it would have run down the side of the steep side of the volcano, and all these lines look a little bit like lots of ropes.
A bit like...
A bit like that, yeah. And in Hawaii, this is called poe lava.
Ah.
There's loads of things you can vary in this experiment, such as the amount of baking powder, the amount of washing up liquid, and the amount of vinegar. And all these sorts of things will have an effect on the actual eruption that you get. All these ideas are available on our website, where there's a fact sheet which will tell you how to do the volcano experiment and all the things you can change.